Hello friends, today we are going to discuss about rainwater harvesting. Uh, Regarding the rainwater harvesting that we are going to do in our homes, and this can be applicable in flats also. But basically today's discussion will be particularly taking about in a common people house, how we can do the rainwater harvesting. From the civil engineering point of view, what are the elements to be designed? So basically, let's discuss what is rainwater harvesting that we are going to talk today. It's nothing but that usually uh, when the rain comes, the water uh, which falls on the top of the roof of a house and also on the surrounding portion, it usually goes to the sewage, and that pure rain which is falling on our land is basically wasted. So in this new day and age, it's high time that we provide rainwater harvesting, that is to harvest this rainwater to our beneficial purpose. So the thing what we are going to do is just collect this rainwater and let it not go to the sewage. So instead, we'll be routing this rainwater from on top to a pipe to our filter and to our well. So we'll be just converting that well into a rainwater harvesting system. That is, we will be providing a filter like a bed around the well so that water can be filtered to downwards, and this rainwater, it will recharge our groundwater table level. That is basically what is happening. That is, the rainwater is basically recharging the groundwater of our plot. Instead of this rainwater going to the gutter and getting wasted, we'll be collecting the rainwater and recharging our ground level so that during the rainy season the water table will be recharged, and we can use that water in the non-rainy summer season also. So, without any further ado, let's start our discussion. So, first of all, the rainwater from our home, it will be routed to a pipe and to the chamber, as you can see here. This chamber will be having a dimension of the around 45 by 45 centimeters. So the water from the rooftop will be collected in this chamber, and from there it can flow to the filtration medium. So next, let's talk about how the filtration medium I have set up. Normally, in general water filtration medium, you'll be saving that fine sand will be on top, and below that will be the coarse aggregate. So usually this is done because most of the filtration, the minute filtration will be done by the sand medium. So after that, when the water flows to the coarser medium, the flow of the water we are getting out of this medium will be high. This is the purpose required in usual filtration of water. But in this scenario, in this rainwater harvesting system, what we need is that the water coming during the rainy season, it should get into this medium into a faster pace. So that is why we are putting a coarser medium on top, and we are putting the sand, that is a fine filtration medium, on bottom. So the water coming during the rain will get quickly discharged into this filtration medium. And another benefit of this is that as in top we have put a coarser medium of filtration, the minute impurities will not be filtered by this medium, and the water can easily pass through. And this top, our coarser aggregate filtration medium, it will not get clogged that much easily, because in fine filtration medium it will get clogged very fast, because as the pores through which water can flow through is very minute. Thus, we can prevent frequent cleaning of this our filtration medium. And one more thing you can do is that on top of this filtration medium, you can place a net over it so that bigger impurities like leaves and all, you can clear it off very easily. One more thing what we have done in this filtration medium is that we have put a coarser medium in bottom portion of our well. So this coarse medium which we have placed at the bottom of a well is to provide a uninterrupted flow of groundwater into this well, because when we dig a well, in this top portion you will see there is no water coming to the well. So as we approach the bottom of the well only, the water streams from the ground will be coming into the well. So when the water streams are flowing into this, we'll provide a coarse medium so that water can easily flow into the well. Or else, if you provide a fine medium here, in a long run, the flow of water into the well can reduce. And also, another thing which we have done is that while casting the well ring, we'll be providing some 1 inch PVC pipes in this bottom portion or well rings. So this will also help enable our streams of water from the ground to flow into the well uninterrupted. And next about the length or up to what depth we should provide this coarse aggregate filtration, then sand filtration, then again this coarse aggregate. It all depends upon the site which we are constructing our well upon. So as a thumb rule, you can just provide approximately 1 meter of coarse filtration medium, and next most of the portion of the well can be sand because this is the portion where most of the fine filtration takes place. And then at the bottom we can provide the coarse medium, that is when while digging the well, when you see the water from the ground coming to the well, from that portion you can provide this coarse medium. Next, another important thing you have to take care is that you should always cover your well on top, because usually our like forefathers used to tell that you should not cover the well, and the well water should be exposed to the sunlight, but this is not scientifically true. In the olden days it can be there was no issue of maintaining the purity of water, because we used to take water from well with the help of a cup and a rope. So the water used to get always shaken when we take the water from the well. So in that process, the aeration of the water takes place in that process. But nowadays, as we don't use that method of taking water, we just take the water from the well with the help of a pump. So in that case, the water is not shaken up. So the proper aeration of water doesn't take place. So if we place a stagnant water and it is exposed, and if it's in a stagnant water and it is exposed to sunlight, then what happens is that fungal growth and other small insects growth will take place in water. So this will ruin the quality of the water. So that is the purpose. It is always wise to cover the top of our well. Next, what we have done is that we have provided a submersible pump with a sensor. The purpose of this, I will explain with the help of two cases. First, let us take, we have, this is our water tank, and this is second case, and this is our water tank in our second case. So in the first case, we will be pumping the water into our water tank when the water in this tank reduces to the bare minimum. Okay. And in second case, we'll be providing a sensor, and as soon as the water reduces in the water tank to a certain level, which is very less compared to in the first case, the sensor will get activated and the water will be pumped. So suppose the storage capacity of this tank is say 1,000 liters, both the case 1,000 liters. So in case one will be required to pump 1,000 liters in a single go. So in the second case, we'll be required to pump say only say 100 liters in a single go. So what is happening is that in a single go, the water required to fill the our top of the tank in the second case is only 100 liters, and in the first case it will be 1,000 liters. So what we are doing is that we are taking 1,000 liters of water from this well into this tank. So if in a site where the water quantity available in this well is say only approximately 1,000 liters only, the quantity of water in this well will be completely finished off when we pump it in a single go. But in the second case, as we require only 100 liters in a single go, the water will be pumped from this well, and still approximately 900 liter of water will be remaining in this well. So at a given point of time, sufficient quantity of water will be available in well, and there will be no shortage of water in our water tank also. Before the next 100 liter of water we need to pump into this water tank, the 100 liter water will be replenished into this well from the groundwater, because it takes some time for the water in the well to be replenished by the groundwater. So if the rate of flow of groundwater into the well is very less, this second case will give us sufficient time for the water in the well to get replenished. So that is why we are providing a submersible sensor pump. So this will be very helpful in the situations where the groundwater table is very less, or the flow of water into the well is very less. And another thing is that if it is a sensor pump, we don't need to switch on and off the pump as the water finishes up in water tank. It will just keep on topping up our water tank frequently, so we don't have to bother about it. So I think it's very efficient to provide a submersible sensor pump. And I have also uploaded this AutoCAD drawing of this rainwater harvesting system which I have done, and the link for which you can find in the description section. So I think you can also use it by doing the slight modifications to dimensions as per your requirement. So this is the rainwater harvesting which I done in my home. So this is the outer wall which you can see here, and this is the well which I completely covered it up, just given a hole for the submersible motor to be immersed in. And as you can see, I covered the top portion with a net so that I can easily clear off the leaves which are falling on top. And then as you can see at the end, there are two pipes coming in. The one is from the rooftop and the other pipe is taking the rainwater from my surrounding plot area into the filtration medium. So this small video was helpful for you to understand how to provide a rainwater harvesting system in your home. So if you like this video, please do like, share and subscribe. Thank you. Until next time.